Division of Interplast, with responsibility for business development, planning, sales and marketing. Can we please welcome Mr. Miro with a round of applause.
Hi, good morning. My name is Miro Donabedian. I want to share a secret with you. The picture that you are seeing on that wall, was taken in 2009. So I'm pretty much in good shape, I guess. Anyways, before I start, I want to distribute some of the samples of the spray foam that I'm going to discuss. We have some samples, so it will be distributed around so you guys can touch and feel it. And also on the end of the session, I'm going to ask some questions and give you also gifts, because I find people are midday and you are sleeping maybe, so you should be more awake. So let's dive into our presentation.
Yeah. Not next.
First, I want to give you a brief overview of the flow of the presentation. We will start with the introduction, then we will go with a different spray foam, how it works, the different categories, the advantages, disadvantages. I'm assuming some of you guys are not aware of how spray works, so I'm treating the audience as knowledgeable and also people who are new on this. Once I give you the overview, then I'm going to talk about the challenges on the spray foam. Even today in the morning I got some phone calls about some challenges you are facing. So spray foam is a sensitive product, so we should be careful how we apply it and use it. And afterwards I'm going to talk about the spray foam systems that we have currently available. And afterwards we'll conclude with applications and the takeaways, and afterwards the question session. Just a brief introduction. Our division is part of the Harwal Group. We are a global company. We are not a local company. All over the world. We are the biggest plastic converters in the GCC region, 200,000 ton. And IP Harwal is one of the divisions. It's competing of the plastic as well as the polyurethane. Right now we are basically on the polyurethane division. And it's a worldwide division, and what I want to say is that it's one of the oldest companies, the group, and also in this part of the world. We have a diversified product range. Today, what we are going to talk about is the spray foam, which is part of the building products. Innovation is our culture. It's also in our DNA, I would say. We have a group of people, day and night, they think about how to innovate. And our chairman drives, Mr. Harwal drives all these innovations from A to Z. And that's why we started to be working in polyurethane from 2009 and onwards. Our product systems, as you see, is a wide category. Today our focus is on the spray foam. We cater to all other rigid foam applications, trucks, cold stores, infused lamination, and spray foam is one of our good products that we are currently capturing in the market. This shows just quickly our capacities that we have in our factory, which is located in Dubai Investment Park. One key feature I have is that we also have whatever we develop, immediately we roll out and we test in our own facility. We have our laminators, we have our presses, we have our own machines, so we don't use our customers for our developments. We are our customer before we give our product to our outside customers. So, basically what is spray foam? Spray foam is two components, the polyol, the blended polyol and the MDI. You mix them together with a positive displacement pump machine, the spray machine, and then you spray it. How it works, the liquids come and react in the mixing head, and I want to show you, like, there is a video here we can see with one of our sites in Ras Al Khaimah. This is our spray foam. It's in hot temperature, like it was 2-3 weeks ago this video was taken. we are basically spraying one of our customers' roofs. And important is the blowing agent, which is the gas in the cell. This has a critical impact on the insulation value of our spray foam. So depending on the glass that we are using, you will achieve different insulation values, which will come later in our presentation to see what is the impact on the different spray foam systems. As you see, like the guys doing some touch-ups on the corners in hot Dubai conditions of 40-45 degrees outside, and you can see a nice smooth surface, which is our premium product spray, rigid foams. As I mentioned about the gas that was important in the spray insulation, it has started with CFC. It is going down from left to right. As you see right now, we are phasing out HFCs, and now we are at the last stage where we have the HFOs and the CO2 which is coming from the water. So this is the latest stage of our evolution of using blowing agents in our spray foam. And each one has a distinct criteria. As you see the far end of the graph, it is ozone friendly and also low global warming potential. This is what we are striving for. The properties of the blowing agents, what is important here to see is the boiling point. If you go from left to right, for example, the HFOs have a low boiling point, 19 degrees. The 1,4-1B system has 31 degrees boiling point. This is a challenge sometimes when we are applying the spray foam in this part of the region where temperatures can soar all the way to 50 degrees. So one point is the boiling point. The second point is the thermal insulation. As you see, like the water-blown system, the water has a lambda of 16.6, which is the highest, which works against, in a way, what we want. We want the low insulation lambda, but when we go to the water, for example, that's where we get penalized on the insulation value. We have two categories of spray foam, closed cell, open cell. If I want to give you an example just to keep in your mind, one is gold and one is silver. Silver is the brother of gold, but of course silver is much cheaper than gold. So the gold is the closed cell because it is strong, it is closed cell, it has a very good thermal barrier, it has a structural strength, and also the insulation value is much better than the open cell. The open cell is, it has also similar properties, but it's weaker. But it has also some distinct applications where we can use. What are the advantages? As you can see, there is a lot of advantages. You don't need to apply glue on the wall to apply your spray foam. You just spray it, boom, it glues on it. It prevents moisture penetration. It's a good insulation value. It reduces the load inside your office or your room. If you're properly insulated, then you don't need to put a lot of AC. Your AC costs go down. You can multi-layer it, you can apply polyurethane over it, you can put protective coating over it, and it can act as a permanent barrier as an insulation. So it has a lot of good advantages. And it's an air barrier, it prevents the moisture penetrating, as well as it seals the whole area, 100%. So this is very important, especially, let's say, in North America, where power is very expensive, so everybody is trying to reduce their energy costs, not like here, but other places is very critical. Spray foam saves energy, as I mentioned. In US, for example, you can see the biggest consumption of energy is wasted in heating and building the commercial buildings, as well as the residential buildings. I would say this one also similarly applies for Dubai, but instead of heating, we just put cooling, because we are running the ACs 24 hours almost. So if you are saving almost like 40% of the energy in US is spent on heating and cooling. So if we basically do proper insulation of our buildings and our houses, then also we can reduce the cost of the energy by 30 to 40%. So this shows that spray foam is a very critical element that can be used to save energy. And of course, if you compare all the different categories of insulation, the spray foam, rigid foam is the best form of insulation, as you can see in the bottom graph. It surpasses all the other sorts of insulation. So what are the challenges we are facing with the spray foam? Quality issues. The applicator could be using the wrong machine, not properly calibrated, not qualified. Maybe they are tampering with the chemical. The conditions, the summer is 50 degrees, the winter is 20 degrees or 15 here, wind is blowing. So there are many variables that can affect your spray foam when you are applying. Also, there is the sustainability and impact on environment. Right now, as you guys know, 1,4,1-B is phasing out. So we are pushed more and more to use alternative blowing agents, where those ones also have their challenges, and it has to be fully developed on a commercial level, similar to 1,4,1-B performance. In certain areas there are still gaps that everybody is trying to close it, but these are the challenges we are facing, and also availability of those alternate blowing agents, the price. Also, like we are having a pressure from the local regulations to reduce 1,4,1-B usage. For example, us next year will be our last year where we can import 1,4,1-B. After 2024, we cannot import 1,4,1-B. So what is our plan? That's why we are working on new alternative developments to make sure that once 1,4,1-B phases out, our customers are trustworthy and they can continue using our new systems. Now, we come to the core of the discussion. These are the systems that right now we have commercially available for spray foam. From left to right, we have the 1,4,1-B system, then we have a water-blown system, high density, then we have water-blown low density. We have a PIR spray foam. If people have some specific applications where fire is required, we have the PIR spray foam. And then we have the open cell foam. If you look at this table very quickly, you will notice each one has different characteristics, which I will show in a summary on the next slide. But for example, the open cell, the insulation is the weakest on the whole chart. Compression-wise, also the weakest. The PIR, for example, ranks very good on all the areas, but the price is a little bit more. So each one has positives and negatives. It depends on what you want to, what is your application and what is the specifications. So if I compare like all these spray foams that we have, as I mentioned, you know, each one has a distinct identity. What I rated was when I'm putting the pluses highest, it means that in that category it has the highest ranking. So if you are looking for an application where you want high density and you don't care about really the insulation, right? Then water-blown high density 3040W will be a good product that you can use. If you don't care about the strength and the insulation, you just want to feel, you know, opening, right? Then open cell will be the best, because in the open cell the density is the lowest, so you can get the highest yield on the input that you are putting. If you are looking for a robust system where quality is important right now, insulation is important, then basically at this point I would say the 1,4,1-B system is the best, but it has an impact on the ozone environment requirements. So it all depends on the application and what your customer requirements are, the specifications. According to that, we can cater the spray foam for you. What are the applications? Mainly in this part of the world, it's been used for insulation of the roofs in villas or existing structures where there is a leakage, for example. Like I know that when it rains in Dubai, all the roofs, you can see how much water is coming and leaking. So on the right, I put you an example where you can retrofit your roof. All you have to do is go on the roof, clean it, spray, maybe apply another coating, and boom. First, you increase your insulation of your roof, so it becomes even a better roof, and you stop all the leakage, all the water leakage stops, and you also stop the heat transfer where there are heat barriers. So it has a lot of applications. In this part of the world, I would say mainly is for villas, houses, and also like all over the world you have LNG tanks, swimming pools, cold stores. If you have a cold store, for example, which requires minus 20 to minus 40 degree application. Instead of going and putting like slabs of foam, you can go in and spray, which makes you a nice seamless insulation. So you can see it has a variety of applications, also for prefabricated houses, for example. Okay, what are the key takeaways? The first one is that the spray foam is established as a very good R value, insulation value. That's a given. Second one is that we have different diversified applications and systems for different applications. Each one has its advantages, disadvantages. None of them is plus on all the rankings. One is high density, the other one is high cost, one is low insulation. It will depend on the application, and then you will select the system that matches your requirement. But 141B system, as of now, I would say is the most robust system as of now. I mean, we are selling a lot of them still now, but we have customers who are also requesting that no, you need to give us a green system. That's why we are giving also the waterborne system. And that's the end of the presentation. So now I'm going to ask some questions. The first question will be, out of the 4 systems that we have, which one has the highest lambda? Who can answer this question? We have the 141B, we have the PIR, we have the water-blown, we have the open cell. Out of these 4 systems, which one has the worst insulation? Put it this way. Open cell. Let's give a giveaway to our friend here from Momentum. Thank you. Next question. Out of the before that, what is the slogan of our group?
Innovation is our culture.
Excellent. Here, Mr. Shamsuddin, our giveaway. And number 3, I will make this one hard. Number 3, if a consultant comes and he tells you, I want on a 5 centimeter roof insulation, the best lambda. I don't want to input more, best lambda and best yield. Meaning that I don't want to put more material and I want to get the best insulation, right? On a 5 centimeter roof, which system would you recommend? The 141B system, the waterborne, 141B. Mr. Bayarlaki. Okay, these are my questions. Any questions from you, sir? No questions? Okay, so you can come to our booth L25 and we'd like to give you more gifts and discuss with you and have a good time. Take care. Albert.